This tutorial is going to cover section 7.6 and 7.7, circles and parts of circles, including arcs and sectors and segments of a circle. I've got these definitions up here. If you need to pause the video to write them down, please do so. Let me talk about them here for just a minute. The definition of a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. When I ask for a definition of a circle, this is what I want. I don't want a circle that's 360 degrees, or it rolls, or it has no angles, or it's round, or any of those things. I want to understand that it's a set of points. Those points are two-dimensional. They lie in a plane, and all of the points are going to be a same distance away from a certain point. That's called the center of the circle. A radius is a segment that has one endpoint on the circle and the other endpoint in the center of the circle. Excuse me, DE is a radius. A chord is a segment that has both endpoints on the circle. Let me draw a chord. There's your chord. That would be chord BC. A diameter is a chord that passes through the center of the circle. Well, there's AC. That is a chord. It has both endpoints on the circle, and it passes through the center E. A central angle is an angle whose vertex is the center of the circle. Wow, I kind of missed the line, didn't I? Angle CED is a central angle. A few more definitions. An arc is a section or part of the circle. I have the whole circle. An arc would be just a part of it. The red part that I just drew would be called arc AB. I put the beginning and the ending of the arc, and the little curve on top tells me that it's part of a circle or an arc. AB has a central angle that is less than 90 degrees. It's called a minor arc. And because it's a minor arc, I only need two letters to talk about the arc, or to name the arc. A semicircle is an arc who measures exactly 180 degrees, or half of a circle. If I'm going to talk about a semicircle, I need three letters. The reason for that is if I'm going from A to C halfway around, how do I know if I'm talking about this portion of the semicircle, or this semicircle, or if I'm talking about this portion of the circle? The green one I could call arc ABC. The blue one I would call arc ADC, and I could equivalently call it arc CDA. But notice it takes three letters to talk about a semicircle. A major arc, oops, let's try that again. A major arc is an arc whose central angle measures more than 180 degrees. A reflex angle, let me draw or sketch here a major arc. Notice that it goes more than half the circle, so its central angle has to be more than 180 degrees. I would call this by three letters. Don't call it A, B, C, D. Just give me three letters. Where it starts, where it ends, and one point in the middle. You could call this ABD. You could call this ACD. You could call this DCA. You could call it arc DBA. Any of those would be fine, but notice I used three letters but not four. I can't, however, call it arc AD because arc AD is the minor arc. And finally, what's the circumference? The circumference is the distance around the formula. Basically, it's like the perimeter for a circle. One of the things we find, the measure of an arc, and be careful with this because there's a thing called a measure of an arc, there's a thing that's called the length of an arc. The measure of an arc is very easy to find. It's just the measure of its central angle. So here I let AC be a diameter, and I want to know what is the measure of arc AB. Well, the measure of arc AB is the measure of its central angle. It must be 100 degrees. What's the measure of arc AD? Well, arc AD, notice it's going to have a central angle that is less than 180 degrees. It starts at A and goes to D, what I would call the short way because there are two letters. I know that ADC is 180 degrees, And I know that arc CD is 35 degrees. So the measure of arc AD must be 180 minus 35, which is 145 degrees. And the measure of arc ABD starts at A, goes through B, and follows till it gets to D. Well, I'm 180 degrees to get to C. 35 more will get me to D. This time 180 plus 35 is going to be 215. So the measure of arc ABD is 215 degrees. Now instead of, let's see, now instead of finding the measure of an arc, I actually want to find the length of an arc. Well, the length of the arc is going to be based upon a proportion of its circumference. Notice that this circle has a radius of 4. What's the circumference of the circle? Well, the circumference of a circle is 2 pi r. So in this case, the circumference is going to be 2 pi times 4, which is 8 pi. Now, think for a minute. If I were going half a circle, if I were going to a semicircle around, wouldn't my circumference be half of the entire circumference? It would be, and so my length of arc ABC would be 4 pi. Well, one way I know that is because the measure of arc ABC is 180 divided by 360, which is a half. The proportion of the arc is a half times 2 pi r, which was 8 pi. I'm going to do the same thing here for trying to find the measure of arc AB. This is a portion of that entire 8 pi. It's how much of the proportion is it? Well, it's 100 out of the 360 degrees times the circumference of the circle, which is 8 pi. 10 goes into both of these. Notice that 2 goes into 10 and 36. 2 goes into 10 5 times. That's a 5, believe it or not. Let me try that again. 2 goes into 10 5 times. 2 goes into 36 18 times. 2 goes into 8 4 times. 2 goes into 18 9 times. And when I get through with this, my answer is going to be 5 times 4 times pi, which is 20 pi, divided by 9. Maybe not the prettiest number, but it is an exact number. What's the measure of the length of arc ABC? Well, we just did that one, right? Because that was the easy one. It's exactly half of 8 pi. Half of 8 pi is 4 pi. If I were going to do the length of arc ABD, I would do 215 over 360 times the circumference, which is 8 pi. Hopefully that all makes sense. All right, a sector is a region bounded by an arc of a circle and the 2 radii to the arc's endpoints. Basically, I have 2 sectors of this circle. I have the yellow sector and I have the white sector. And I want to find, first of all, what is the area of this circle? Well, I'm going to have to come up with something here. I probably should have put the 4 inches again, so we actually could come up with an area. What's the formula for the area of a circle? It's pi r squared. So in this particular case, the area is going to be pi times 4 squared, which is 16 pi. When I'm trying to find the area of a sector, all I'm trying to find is a proportion of the circle based upon the area, which is going to have to depend upon how many degrees the measure of the central angle is. So over here I've got the area of the circle is 16 pi, and now I want to find the area of the white shaded sector. Well, the white shaded sector is 110 degrees out of 360 degrees, and that's going to be times the area of the circle, which is 16 pi. I take the proportion of the central angle to the whole circle, which is 360 degrees, and multiply that proportion by the area of the circle, which is 16 pi. Once again, I can divide both sides by 10. 4 goes into 16 4 times. 4 goes into 36 9 times. And my answer is going to be 44 pi over 9. That's the area of the white shaded uh, sector. Incidentally, if you think about what the area of the yellow shaded sector should be, it should actually be 16 pi minus 44 pi divided by 9. Hopefully that makes sense, because the whole circle together, or both of these sectors together, should add up to 16 pi. But that's not normally the way we would do this, so let's look at it like I would probably expect you to work it on the test. What is the area of the yellow shaded region? Well, if the white shaded region, the central angle for the white shaded region is 110 degrees, then the area for the yellow shaded region must be 250 degrees, so the whole thing equals 360 degrees. So the yellow proportion of the circle is 250 degrees out of the total 360 degrees, and I'm going to multiply that by the area of the circle, which is 16 pi. I try to keep these things where those 10s cancel out and I don't have to do so much math in my brain. But 4 goes into 16 4 times. 4 goes into 36 9 times. And so this time the area of my yellow shaded sector must be 25 times 4, which is 100 pi over 9. That would be the area of my yellow shaded sector. All right, a segment is kind of like a sector, except it misses the triangle in between. The definition of a segment is a region bounded by an arc and the segment containing the arc's endpoints. So I've got this little blue region down here, and that is going to be my segment. How do I find the area of a segment? Once again, I need to put up the radius, and I've had so much fun with 4, I'll just let this one be 4 inches also. Okay. Now, what I'm going to do is I'm going to find the area of the sector, and then I'm going to subtract the area of the triangle. And I promise you it's not going to be a real pretty number, but it shouldn't be that particularly hard to do. What is the area of the sector? Well, the area of the sector is the measure of the central angle divided by the area of the whole circle, or the degrees of the whole circle, which is 360, times the area of the circle, which is 16 pi. Well, 60 goes into 360 6 times, so I've got 1/6 of 16 pi. 2 goes into 16 8 times, 2 goes into 6 3 times, and so the area of the sector is going to be 8 pi over 3. But I can't do just the area of the sector. I have to subtract from that. Let's get a different color besides blue. I have to subtract the area of the triangle. Okay, how do I find the area of the triangle? Well, the good news is in this case I've got a 60-degree angle on the top. These are radii of a circle, so these two angles have to be the same. They have to be the same and total up to 120. So both these angles have to be 60 degrees. I've got an equilateral triangle whose side is 4 inches. Remember that the area of an equilateral triangle is the side squared times the square root of 3 divided by 4. So in this particular case, with S being 4, I'm going to get the area is equal to 4 squared times the square root of 3 divided by 4. 4 goes into 4 squared 4 times, 4 goes into 4 one time, and my answer is 4 times the square root of 3. So the area of the triangle is 4 times the square root of 3. The area of my segment, this blue shaded region, must therefore be the area of the sector, 8 pi over 3, minus the area of the triangle, 4 times the square root of 3. And for now, we're just going to leave it in this exact form. You can plug that in the calculator to get a decimal answer if it's needed. All right, try some problems on your own. Go ahead and pause the video and try to find the measure of these three angles. BD is a diameter. I am trying to find the measure of arc BC. Notice it said measure, not length. So all I need to do is find the measure of this central angle. Well, if BD is a diameter, this whole angle here is 180 degrees. 180 minus 32 is 48. So the measure of arc BC is 48 degrees. What about the measure of arc BAD? BAD must be a semicircle. The measure of arc BAD is 180 degrees. And finally, what about arc AC? I start at A, I end at C. I don't go through D because that would be more than 180 degrees, so I must go this way. There are a couple ways to get the measure of this angle. What I think I'm going to do is I'm going to say that 62 and 132 is 194. The whole angle is 360. What is 360 minus 194? It is 166 degrees. So the measure of arc AC must be 166 degrees. Problem 2, this time we're going to actually find the length of the segments and leave our answer in terms of pi. Notice this time I actually had to give you the length of the radius. Go ahead and pause the video and try these now. Okay, the circumference of the circle is 2 pi r, so the circumference of this particular circle is going to be 2 pi times 3, which is 6 pi, and each of these arcs are going to be a proportion of that 6 pi. Well, BC, if we remember from the back, BC is 48 degrees, so my answer is going to be 48 out of the total 360 times the circumference of the circle, which is 6 pi. Now I'm just going to do some simplifying. 6 goes into 360 60 times. And let's see, 12 goes into 48 4 times, and 12 goes into 60 5 times. And so my answer is going to be 4 pi over 5. How about the length of arc BAD? Well, that's exactly half of the circumference, and so I'm not going to have to do any work at all. I know that the length of arc BAD is 3 pi. And then how about AC? Well, I'm going to cheat back here real quick. The measure of arc AC is 166 degrees. I'm going to take that out of the total, 360, and I'm going to multiply that by the circumference of the circle, which is 6 pi. Once again, 6 goes into 360 60 times. Wow, I'm not real sure. It looks like I can just put a 2 in there. 2 goes into 166 83 times and goes into 60 30 times. And so the length of arc AC is my favorite number, 83 pi divided by 30. Problem 3, solve the area of the shaded region. Leave your answer in terms of pi. Okay, this time, the shaded region, which is the yellow shaded region, is going to be a proportion of the entire area of the circle. And the proportion is going to be the 100 degrees of that central angle divided by the 360 degrees of the entire circle times the area of the circle. Well, remember that the area is equal to, what on earth is that? The area is equal to pi r squared. So in this particular case, the area is going to be equal to 25 pi. Let's multiply 100 over 360 by 25 pi. Let's see, scratch out the zeros. 2 goes into 10 and to 36, which will give me 5 and 18, and I'm pretty much stuck. So my answer is going to be 5 times 25 times pi, which is 125 pi, divided by 18. I asked you to leave your answer in terms of pi. I don't really like decimals. That's the answer I would look for on a test. And finally, problem 4, solve the area of the shaded region. Give an exact answer, and then let's give the answer rounded to the nearest tenth. So let's begin with the exact answer first. I'm going to find the area of the shaded region. And the area of the shaded region is going to be, I'm sorry, the area, I called it shaded region. Let's find the area of the sector. The area of the sector is going to be 90 out of 360 times the area of the circle, which we know is 25 pi. Okay? And so we get 90 out of 360 is the same thing as 1/4. And the area of the sector is going to be 25 pi divided by 4. But I have to subtract the area of the triangle. So what is the area of the triangle? Well, if this is 90 degrees and these two angles here are the same, remember that these are radii, and so I've got an isosceles triangle, this must be 45 degrees. Well, if it's 45 degrees and this is 45 degrees, if this is 5 centimeters, this is 5 centimeters, my base is 5 centimeters, and my height is 5 centimeters, the area of the triangle is going to be 1/2 the base times the height, which is half of 25, which is 25 over 2. So the area of the triangle is 25 over 2. And so I'm going to subtract the area of the area of the triangle from the area of the sector. I'm going to get 25 pi over 4 minus 25 over 2. And you can leave it like this. I'm going to go ahead and simplify by saying 25 over 2 is the same thing as 50 over 4. And so therefore I can get my answer as 25 pi minus 50 over 4. And I could also call that 25 times pi minus 2 over 4. But this is my exact answer, 25 pi minus 50 divided by 4. Now, what is that rounded to the nearest tenth? Well, let me get out my calculator. Let's see if I can do it with this calculator. Please tell me I can. We'll find out in just a minute. Is there a pi button on here? I don't. Oh, there it is. It says pi. How about that? All right, so let's do 25 pi minus 50 divided by 4. And that'll see if that works. I haven't ever tried to use this calculator. Clearly that doesn't work. All right, so let's try this again. Let's do pi, and then let's multiply that by 25. And then let's subtract 50. And let's take this number and divide it by 4. And my answer is, I didn't round it to the nearest tenth, is approximately 7.1. Looking back at the calculator, approximately 7.1. So it is possible to take a calculator and get 25 pi minus 50 over 4. Might be hard to figure out exactly what that number is. A very good approximation by the calculator is 7.1. We'll be doing more of these in class. Please take time to try these, maybe make up some of your own. We may even end up doing some trig functions instead of just using 30, 60, 90, and 45, 45, 90 triangles. See you in class.